Oh, thank you. No, thanks for having me. It's great to appreciate the introduction and time. Um, but yeah, so my name is Michael Berry. I'm kind of very much an interdisciplinary forester. And I recently came back from living in Australia, where I was a research fellow, really doing a lot of research consultancy work, forestry sector, kind of combining forestry engineering. And right now I actually work for them up in Page, Arizona. I kind of run the engineering. So kind of, I still connected with forestry engineering and develop businesses. So kind of in three different disciplines fully, but really just having a lot of fun. Some of the stuff I want to talk to you today is really, I want to give you a glimpse of what Australian forestry is, given the context of what I was doing last, and go through some case studies associated with forests out there and the biomass. And again, trying to kind of connect forestry and business, develop viable market. And some of that's obviously related to Southwest and Arizona. Well, all parallels there. But yeah, so kind of Australian forestry, really two different resources. I'll go with that, and then those case studies. Open up for questions. But very much, I'm not here to lecture, here to chat. Feel free to ask any questions along the way. I have more than enough slides, and I'm not going to go through every slide. Some of these slides I actually pulled out because I work geared towards industry, that market development side. I'll kind of hit on some of the highlights of what overseas to kind of give you a perspective of what's going on in different places. So does anybody know anything about Australian forestry? Well, I can just make everything up. That's great. No, so there are some parallels with different, right? And different market context, environment, and everything else. So I was centered on pointer. Maybe this is a pointer? No. I can just, so in the red box, that's kind of where I was located. And in that area, we had kind of industrial pine plantation, what they called exotic pines, pines from the south, exported to Australia and grow very well. And a lot of that's exported as saw timber and other products. And then we had kind of tropical forests in the north. Down along the side, we had a lot of different pine species, exotic species. Interwoven between everything else was a lot of native hardwoods, a lot of the eucalyptus. Imagine when you think about Australia. In the south, I spent, I was all over the country doing, but south in Tasmania, there looking at some of their native eucalyptus that were utilized for kind of export markets for saw timber, biomass, and chip. And then when you go to the west coast, there's another kind of forestry hub. You can kind of notice all the forests around the exterior because the middle is desolate and there's nothing. So on the west coast, we had a lot of other pine plantations, a lot of blue gum as well, and that was a chip for pulp overseas. And a lot of the major markets, and there was also blue gum kind of throughout the south. But a lot of the markets were geared to shipping, a lot of this chip, a lot of the timber over to China, and in chips, in timber, but also in pellets. Pellets was an emerging industry, kind of connected with the Japanese market, and it's really market-based, right? So the Japanese market had the issues with the power plants, and a lot of their power generation pellets and wood products. And we had some excellent sources for wood coming out of Australia. So an interesting landscape. And of course, there were domestic markets. And actually, they're kind of a net negative on what's imported products, but there's an awful lot going on. A lot of the companies are chasing that export market. Australia is a country the size of the US with a population of Florida. So there's not many people and a whole lot of resource. Anyway, but we were located on a lot of these case studies are from the East Coast. They're related to Australia, or related to Arizona. In Arizona, obviously, there's a lot of public landowners. Australia, there was kind of a bit of both. And a lot of the private land was what we were working on, similar issues. Mixed species, diversified markets, some very long haul distances, similar to what we have here in Arizona. Yeah, there was a lot of fires, last few years. So fire reduction, there were same issues with labor shortages, not getting enough, people to do trucking, people to do harvesting, people to do forest management. People from all over the world working with these different forest managers. Hard to get local people to get interested in the sector. And we have parallels in New Mexico. Same issues. Just like here, trying to get stronger. Unique landowner needs. It was a little bit different over there, and I'll go into that context. But biomass utilization was a common theme, emerging market. We had a lot of ground-based options. So you guys are studying forestry, but you have all different disciplines, right? So, I'm by nature kind of forest operations, forest skewed towards market development, kind of get, but also the operations and the economics, like a part-time economist. It's just how make business go around. So we had kind of the native hardwoods. So again, from two different resources, we had kind of the pine plantation hardwoods in Queens, and really native hardwoods was uneven age management, had a lot of different gums and eucalyptus, a lot of private ownership. But in this area, effectively, there was a history of high grading, private landowner forest, basically ill management of the resource. A lot of overstock stands, a lot of unhealthy stands, a lot of fire issues, and we were trying to, and then public opinion around actually working in the forest lies in that region. We were trying to get more effective restoration treatment, economically viable biomass from those treatments to pretty much provide silviculture treatments to increase yield and sustainability of these forests and economic viability. And there's a lot of grazing as well, so kind of a mixed use. Again, the bushfires in 2020, that kind of put literally a fire on the Australian public, how we're going to manage. So a lot of the same issues in the Southwest are happening over there. In 2020, when I was there, something like 46 million acres burned. So that's more than half the size of Arizona burned in Australia that year. And it was over 1 billion creatures effectively died or lost habitat. There was all kinds of pictures about wallabies and kangaroos habitat are burning. We had what is out there? The koala. There's pictures of burned koala with the feet. All over national news, but it was all over Australia. We had a lot of projects associated with of this. Kind of moving to the pine plantation. So in Queensland, we had one of the largest industrial owners of 100,000 hectares of land, and that was again a lot of the same Yadi, Pinus carabea, and mixed grow in those very sandy soils of eastern Queensland. And here we pretty much did clear cut harvesting around the 30 to 40 year rotation. And I was working a lot with the value recovery, harvesting operations, and then utilizing it more economically. And some of the work that I was doing was consultancy research, very much industry focused. So the US was kind of the gold standard for research funding compared to Australia. Australia, we had an industry levy. So every cubic meter of material that the companies sold, there was a portion of that went to funding based. But it wasn't very big and it didn't go very far. And I'd worked with one group, kind of the research consultancy group. They went through and looked at supply chains, pretty much the only supply chain kind of optimization operations out, servicing the whole country and all the different industries. And we did targets, we did projects that went through the whole industry spectrum across Australia, kind of brought me all around Australia, but also with targeted companies, including HQP plantations, which one of the case studies I have. But anyway, just a different, we had different forests, we had different markets, at different kind of research scheme funding opportunities, which is just interesting. You know? But what I did was a lot of industry impact change, connect that with a broader knowledge of work from North America, from Europe and elsewhere. And what's interesting is that Australia actually is not really a pioneer in forestry, but we were kind of really just leveraging innovations that happened in Europe, it happened in the States, and applying them, you know, kind of a new environment and making those economic gains. So I want to go through two case studies to exemplify really this biomass supply chain utilization in Australia. The first one really related to the pine. We were looking at forest harvest residue market development. And the second one around that private forestry, looking at the operations, the markets, how much biomass is there, and viability. Because at the end of the day, we, you know, as foresters, as scientists, we have great ideas. We want to make the forest healthy. We want to make everything, you know, better than when we found it. But the reality is we have a lot of good intentions. We don't have markets and it's not economically feasible. No one that can actually do it and make a profit. It's not going to happen without some serious government intervention, which is possible, but not always feasible. So this was really about market development, connecting industry to better the resource and the local economy, but and economically sustainable. So here's a question for you guys. I'm no expert in forestry. I'm curious, you know, what kind of local wood markets and biomass markets? What does it look like? Are there many markets? Where are we at? I'm curious as far as context. Little? Mhm. Okay. 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 Not a lot of solar coming out. A lot of other products. But pretty much you're trying to restore the integrity of the forest, right, through these restoration thinnings and everything else, but there's no market. That's common. And you know, that's why I say we have the best better. We have to connect the dots, and a lot of pieces need to be together. And that's why market development in some of these forest products and connecting resource with operations and markets is incredibly important. Incredibly important. It's really the enabler for sustainable, or it could be in certain contexts. But it just gets you thinking. Every part of a state, right? So we're trying to evolve. You know, look at different markets, look at different regional, different resources, connecting them all together in a sustainable way, ideally, right? But it can be very challenging, especially in the broader socioeconomic context. All right, so the first case study was really this plantation residue. And by the way, some of these plantations were like 30-year-old pines. They could be 30 centimeter DBH and say 500 stems per hectare. You know, pretty good volumes coming off. So really, and actually, Han and I have known each other for 6-7 years. We were looking at some of this waste of wisdom project, so looking at residues and trying to make markets and trying to connect the bioeconomics therein. So I was doing something similar, actually parallel over here. That was in California. But really, you know, after commercial harvest in Queensland, we had a lot of material left over. It was piled up, you know, mechanically piled up and burned. Right, so we had some offcuts, non-merchantable tree tops, we had branches, just a mix of stuff, and often some pretty good quality material. But if there's no pulp market or anything else, it's just then it becomes an operational hazard. You got to do something with it, right? So I worked directly with industry. Okay, well, what can we? What's there? What can we do? Markets, and then try to make a viable market. That's kind of a visual trying to achieve. Really, I came in with the mindset, biomass is a product, right? Opportunity. And there were some emerging biomass markets in the region, still had issues with transportation distance, whatnot, but so I worked with HQP plantations, again, on 200,000 hectares in the area, worked directly with the research manager. We had an EF manufacturer on, had a pellet mill on, we had a very keen harvest operator looking at this problem holistically. And I was kind of the research arm connecting it all together. Super interesting. But again, looking at biomass as a problem. Now, Han will love this kind of stuff. Not everybody else gets excited about operations like, but in a harvesting operation context, cut to length poultry for ground-based option, and then there's hybrids therein. But really, I'm not going to go into the harvesting class. But we're either productizing or cutting the trees down and merchandising them in the field in a cut to length, and then kind of carting it all back with a forward. In that case, when you're merchandising in the field, you have a bunch of material in the field, right? Wherever it's standed. Or we have whole tree harvesting, where we cut it down, we use a grapple skidder, and and the material is a lot more at the roadside, where we then process it, all left over there. It's not as much in the field. Super simple stuff. But it really depends on where your biomass is, quantity it's in, quality it's in, what kind of market that can then. So it starts at the operational base for the economic viability. And I did a lot of bioassessments or biomass assessments. So going out in the field, trying to measure all the material from the whole tree harvesting system up to length. You need to know what you have, what quality it is, diameter class it is, far away it is, figure out how long it take to get it to a market, it's going to, what you can sell it for, how you need to process it, everything else. So we spent a lot of time with the forest industry. Recoverable, probably 10 and 20 tons per hectare in their case. But really it came down to, okay, what's recoverable? That's one thing, but really what shouldn't be there, right? We've uncovered a whole nest of like ill practices with forest operation, that there was a lot of merchantable material left over, that they literally didn't have the right cut sequence harvesters, and they were leaving material because it was either during the processing and handling, or it was just being cut and not optimally. And at the end of the day, these guys own all the forest, effect, trying to get as much yield as you potentially, trying to optimize your recovery, your value recovery up to 30. So it's all kind of connected. And this is a quick aside, but there are many ways to do assessments. I became quite skilled at those different methods and what's good for operations in the field, what's good for scientific base. Do you need to know how much duff is on the ground? How small of diameter class do you really need? Nutrition loss, as well as biomass recovery. Anyway, that's a quick aside, and that's the topic of another paper. But I wanted to kind of get to the point, depending on what method you're actually using, there's a whole lot of variability with those estimates. So you need to, kind of connect that with, it was interesting. I actually just averaged everything out. And that's a quick aside, more for probably. Okay, then you have, so how much material is out there? Get a good, what should be out there, what shouldn't. How's that connected to markets? You have all log markets, sizes. But then you have to look at, okay, well, what are our potential options? And really, when I got out there, we had big piles burning. So it was blue sky. What could potentially be there? We were looking at processing. When I say processing, pretty much getting the raw material, processing to tip or some kind of product form, that in a centralized location. We're going to raw material to a centralized location. We're going to do it in the field, so we're just processing it there. Now in a chip product form, we're going to bring all the raw material further, a further facility, then productize it there. So these different operational paths. And it comes down to, it's a combinatorial. That's something my PhD and did it here too. just trying to solve what's the most economically feasible pathway for the different resources. So in this area, we're looking at moving raw material, what equipment we had, and what studies have been done. A lot of studies. Europe, Raphael Spinelli, we talked with him. Secondly, okay, where are we going to process it? And we had different chipping models of how much it would cost to chip diameter material, volume of the material, the utilization rate of whether we're doing build in a centralized location, facility. Then we had to transport it, right? How far are we transport? Cost transport, in a raw form, pellet form, all these different alternatives. Right? And this is how you solve a problem like this. You solve a market-based problem. And then again, I'm not going to bore you with all details. Then you come through with all, what are the costs of doing all these different pathways? Cost to move material, cost to ship material, and it becomes a big combinatory problem, which is exciting to some, but not very many. Then you figure out all the, opportunities, and then, develop an economic. So I developed a big economic model, looked at volumes, piece sizes, placements, distance, mobilization, moisture, connected everything together, had a great time. But really trying to figure out, what are the best logistics. And what I want to focus here on is, you may have a great idea as a researcher, but if no one wants to invest in it, it's not worth anything, right? You got to convince somebody to actually invest in to make something happen. So it can't happen. Research cannot happen in a vacuum. If you actually want something good, it needs to happen in unison with those doing the work, the harvesting operation, the growers, the owners of the, to make something viable. But anyway, long story short, after a lot of iterations on feasible, a lot of desktop resource, analyzing this, we figured out that for this whole tree kind of operation and the cut to length, probably a Brooks type mobile chipper. You guys familiar with that at all? No, Hans, yeah. So basically, it's a forwarder with a bin on the back and a chipper. You grab material, just one guy, one operator in the forwarder, grabs the material, puts it through a chipper, and it goes into the bin. And that bin you can drive, when it fills up, you can drive to, in this case, we were putting into hook trailers. So in a different bin, and they can be then picked up, transported. And we actually had the luxury of having a pellet. They were very hungry for it. It worked out pretty well. But again, you're balancing the operational flexibility. And that gave them the most flexibility, quality of chip, lower overall per hour cost, because you just have a guy do this operation. And so let's take a step back. So market viability, just because it all depends on the cost. And that really depends on, what is the market price? How much do we have? How can we do it? What's somebody willing to pay? Can we make that operational worth it to a contractor to invest to meet that market demand? And a lot of it has to do with differentiation and the nuances of research, right? So getting a handle on all these areas. And obviously knowing action and profit, all about the market. We don't spend enough time in forestry thinking. But I guess given my background of developing business, looking at, business strategy, it's all about the market. If you can't sell it, you can't do it. But anyway, this is actually a cool story because, when I left, we actually, when I got there, it would just sit. And now today, it's being extracted with the Brooks chipper, had kind of analyzed and recommended. And they're doing about 50,000 tons in the whole tree harvesting coops in this area, using chips as a feedstock for these pellets. They had basically supply contracts with the pellet mill, doing chips for bioenergy in the, as well as animal bedding, and it's viable. The owner of the owner is no longer burning it, having to mess with it on site. They're now selling it at a profit. The harvesting operator is making money during the operations, and the pellet mill is getting a supply they need to then ship to Japan as an export commodity. Everybody wins in this situation, and we are lowering fire risk landscape. It was super interesting. All right. Anyway, that's the first case study. But I want to ask another question. So what are some common civil, or what should they be if they're not being done? You guys are foresters and you're in Arizona, right? What does that mean? They're just thinning, but calling for restoration. Okay. Making thinning economical, trying to, that really needs to be done, right? Or let the fire go through, started naturally. But okay, so thinnings, obviously, that's a main thrust in forestry, and we were trying to do the same thing, native hardwoods. So in our eucalyptus, we were doing restoration thinning, call that biomass, call it whatever you want, material that's going to end, and it's small diameter wood, and trying to make a market for it. We were doing the parallel universe down under. Again, we had overstock stands. There wasn't an appetite for civil treatments. As far as education from the landowner, lack of markets, lack of people to actually do all those same issues. And a lot of small wood from all these stands and could sell commercially, and there wasn't a market for it. So we kind of use the same, use the same concepts. What resource do we have? What operations can we? The same thing repeated in a different area, but using restoration thinning as a product. And it's more parallel to. So over there, we had close to 2 million hectares of this private native forest. This eucalyptus, gum tree, bark, iron bark, all these types of trees that weren't really, there's some saw log harvest on it. Oftentimes the private landowners would take advantage of and migrated and left with a bunch of garbage left over, still a bunch of small trees. But we were trying to figure out, okay, can we make small diameter harvest of this restoration thinning? How much material do we have? Trying to reduce fire risk, increase commercial value. Obviously when you do a thinning, you're getting larger trees left over, so increase the value of the saw log afterwards, and increasing grazing capacity. Before we go further, another side note on some, I was really excited about biomass, obviously, but that's a tiny, like it's a leftover product, right? And a lot of my work in looking at kind of better automation, better sense, better operational practices for all yield, we reduce biomass. Like we're not trying to optimize biomass. We actually don't want most value we can out of the material. But then if we have it there, we might as well make that viable to get rid of it. Anyway, as an aside, because it's the tail wagging the dog. Not that important, but it's whole economic sustainability. But anyway, we did harvesting study. So one particular harvesting study, I was using a small excavator with shear with a skidder. Another one was using kind of more cut to length harvesting, try to grab those smaller diameter wood, figure out the cost and economics of. No one actually had a good idea. That was an exploratory study that's actually still going. But again, going back to the same question, how much material is there? So in this environment, it all depended on the stocking, diameter distribution, and it depended on the market condition, how much saw logs were there, and we had some massive old growth trees, some with large amounts of tree tops and tree. So that's also part of that biomass profile, and it could make about where it is and how much. I'm not going to bore you with numbers. You wouldn't relate to it anyway. We figured out just how much material in a parallel world in the private native forest, and we models to look, okay, well, if we have this kind of stand density and these average diameters, this is our theoretical biomass cover, and this is how much it's going to cost to recover it based on these tools, then to generate a model, an economic model recovery. And then we developed, a kind of cost model for all the supply chain elements associated with this small diameter harvest. And the cost came out anywhere between $40 a ton to $100 a ton. And really the nuance of the coop, nuance of that stand density, that tree size, and how much saw log was left over and where it was. And the reality is not every to extract material from. If you you can be very idealistic and treat all the forests and it's all gonna be great. No, you're gonna end up losing money left and right because you got to pick really what conditions and know what conditions, what operations are, and what's economically feasible based upon that one. So we did some studies around, okay, theoretical biomass, that increases, our filling production increased, the lower cost, as diameter of the tree, our extraction productivity increases, so that lowers the cost. And the stems per hour, probably constant with the operational system, what we were looking at there. But what I want you to understand is and you got to understand those nuances to make a business case. Not everything's going to be viable, even if you think it makes sense. And the project I'm working on now, biohubs, which is really looking at, okay, should we do this at the coop? Should that be a hub kind of at the particular location? Should we do it at a centralized location? Should we connect it with saw log harvest, the biomass thin, amalgamating these materials and using different technologies, and to do it at and in the field as centralized. And we were looking at kind of 3 different products: pellets and miscellaneous products, biochar, paralysis, kind of a combination of products. Because you have this resource, and you may not have the market to sustain 100,000 tons of pellets, right? You may have to diversify and kind of understand those markets and really understand what needs to be upgraded. Do you need green material? Do you need that suitable for that quality and quantity to that? Has anybody seen a carbonator? Super interesting. Anyway, so biochar, they keep saying product of the future. Anyway, there's some interesting ways to actually make commercials. Actually had a study with a massive tire cat piece in biochar at a 10% loss rate. Anyway, very interesting. But there's different technology, right? To kind of reduce biochar being one of them. Paralysis, if you have markets for wood vinegar, bio oil, and char composite, you may be able to make a finance. Really, my side was looking at, okay, is this investment worth it? Private sector development. Can we connect that with forest? But again, at the biohubs, different match that resource, upgrade it, do whatever you need to do, make it suitable for a particular. So we have continued research in there with multiple partners. I work a lot with IEA Bioenergy, which is a national group around the world. A lot of small scale harvesters and trials being proposed and executed locally now. But a lot of this had to do with private resource. So we were almost extension agents. What does it take to convince a private landowner to act about big people? And can you make the financial case? Can you make the operational case? And that kind of buy-in is very, and that's why how you run your business or how you incredibly important. Because if they don't trust you or understand you, there's a mismatch there. It's not going to be viable. It could be a great business opportunity, a great way to do restoration, but if they're not convinced, it's not going to happen. And we learned that multiple ways. So very interesting. So now I kind of want to transition to special topics. So basically, based on some papers generated from this, one looking at site preparation incentive, another one looking at moisture content management. Again, these ones are connected with that. But again, understanding those nuances of economic viability and how, so, just, back to the basics of harvesting, right? So in this context, if we're going to do cut to length harvesting, we have biomass. If we do whole tree harvesting, we often have roadside biomass. That's also connected with site preparation and those economic drivers as well. So again, it all comes back to what resource you have, and it's how you cut it dictates the resource. So what do you think it costs to prepare a coop or a forested section for next generation harvest? What are some of those factors? Because it costs money to plant. You have to prepare the land. What do you think? Have you ever thought about that? Okay. So what do you think some of the factors are? What would make it cost more or less? Yes. Yeah. Yeah, absolutely. That depends on density in your plant, what kind of row spacing you have. But it's also going to depend what materials out there, how big is scattered throughout. That we have, can we actually have guys, men or women, go out there and actually plant? Are they going to have obstructions? Is that a hazard? Is that tripping? We had snakes out there too. There's all kinds of other hazards associated. Anyway, I just want to get you thinking about it. Actually costs money to do anything in the field, right? Even in mid rotation. Yep. 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 True. Mhm. Yep. Yeah, and and it varies, but that's right. That's right in the ballpark. And you're absolutely right. It depends who owns it. What are those economic drivers? Are you doing a clear cut, right? Like we do in the Pacific Northwest, like we did out here in Pine Southeast, or is it uneven age management? It's all connected. But there is, in this particular context, plantation management, which is a little different than ours. Fine, but we had, there's a cost associated with it. And then with a cost, as there's a cost associated, when we go and do a biomass harvest, you're going to reduce some of those costs, right? Naturally. So there's some sort of incentive. And you can read the paper that myself and John Sessions put out, pretty much made an economic model looking at that. And believe it or not, as far as research in forestry, there's an awful lot of little niche. And like looking at the incentive for site prep and on a biomass harvest was never. So that was kind of okay. Well, this is what the work we're doing. We're going to put together a paper around the topic. But ultimately, you're trying to maximize value. And really, we're trying to enable biomass market, right? So trying to capture all those rewards that come from that. Like we said, in this particular context, it can cost, let's say, $500, $1,000 a hectare to do site prep. And if we do biomass harvest, we get that so delta there, right? There's some incentive to do a biomass harvest. That should be captured in the economic model. Now it's harder, it's easier said than done, because in this case, you had to have the grower willing to, recognize that as a cost savings to then, pay a higher price for biomass. But it should be connected with that overall holistic biomass recovery option. So in this case, we found savings of potentially, 22 to $45 a ton per ton of extracted biomass. Just costs, site preparation saving from a cut to length system. Depends on some of those nuances, but that was the range. Or, $4 to $20 a ton. How much do you think, chip is worth to start with? Maybe we can sell it for $50 a ton. So if we can save, it can almost be the same amount we're saving. So then that material, or that we can then sell that biomass at a loss and still make. And that's the holistic part of looking at viability. Anyway, super interesting and super eye-opening to us as researchers, also the industry, and then connected back with the economic justification for doing biomass extraction. Right, something it's kind of a niche research topic that no one thought about, but there are other incentives to do biomass harvest. It depends on the context, depends on the operational landscape, but it should be connected for all viability for it. So, gotta have a quiz, right? So, would you rather sell biomass or $45 a ton or $6 a cubic? I know you're not thinking about cubic meters. Most of the world is. So, real quick, what do you think? No wrong answer. The $30 a cube and a $45 a ton. Okay, it's a trick question. What I want to get at is water. So it depends on the moisture content. So and looking at biomass or forest products as a product, how do you sell that, or how do you cover your money to what you're actually selling? So in this case, if you're going to sell in cubes, or you're going to volume, or you're going to sell by the ton, by weight. So there's a correlation with moisture, all that kind of stuff. But in this area for the pines, if it's about 25% moisture, then $45 a ton is equivalent to $30 a cube. So if we had really, they were buying it on the ton, would you want to have wetter material or higher moisture content? Yeah. If somebody's I can sell stuff by the ton. I'm gonna spray that sucker down wet, right? And likewise, when there's a lot of water in biomass or any kind of wood product, there's also transportation issues associated for the cost. But there's incentives, right? So if I'm going to buy a manufacturer and I say, okay, I'll give you $45 a ton, there's different market incentives. Wet stuff. Then you got to dry it, and then that costs through your, where you can make pellets, which are coming out like 12%. Anyway, but I worked a lot with the forest grower, and I'm like, how you sell it should really moisture content and just understand how that dynamic works, which is again something we don't really think about that often, but effective and how we buy and sell things is incredibly important. And a lot of what we're growing in Australia, so it kind of gets rid of the moisture, right? Not talking moisture anymore, we're talking about volume. We had some pretty cool kind of scanners that go through and actually look at all the volume on truckloads. But anyway, long story short, let's say if we sell it for $45 a ton at 25% moisture content, yeah, that's the same as $60 a bone dry ton. It's same as $30, a cube. And if it was really wet, it's same as $30 a ton at 45% moisture. Anyway, you'd be surprised at how many I was working with didn't understand the concept. And it's like, I think it's fundamental to forestry, but markets, but I asked same questions. I had nobody really understood, and they're the ones selling it and making a profit. But it's a part of that, underlying assumption. If you're actually going to make or lose. as a contractor, as a grower, and as a consumer. Anyway, there was tons of research projects stemming from this work. I did a lot of industry reports and publications, some fun radio spots out there in Australia. I was the token about utilization of biomass, super fun. And some other kind of flavor of these Aussie projects was a lot of this export, dry shipping, economic impacts of log damage, real-time sensor. That's going on throughout the world, as well as Australia. A lot of small-scale harvesting operations, private native forests, short versus long wood, and that kind of classic supply chain question, and phytosanitary supply chain consideration. But really, over there for me, it was all about exports. The interesting market nuances, research associated with helping those industries more viable and export. So I kind of want to end it here by saying, look, in Arizona, and I live in Arizona now, we have a lot of issues, right, with trying to make things economically viable, trying to be the best caretakers of, which is often owned by, but at the same, some of these same and where it's all about collaboration, all about knowing what we have, and it's all about market-based thinking outside the box to connect people with resource and generating new markets for new utilization of material to make restoration efforts. The fundamental element of sustainability. I'll leave it there, but I really appreciate it. Thank you.
Yeah, in case questions pop in.
Yeah, I really appreciate you having me here. I'm excited to get more familiar with the resource in the area and some of the challenges.
Dr. Barry, I'm just curious what ownership over in Australia, what is it percentage of private versus public, federal? I don't know if there's state or federal.
Yeah. So yeah, it is different than out here where you have a lot of federal. Over there it was quite mixed, where there was a lot of private ownership for state lands. We were mostly working on private lands, which is the bulk of that particular, but it varies depending on. And we had some of these large scale plantations, which were actually kind of government incentivized back in to make these wood baskets for the to drive the economy.
This is more of a silviculture market development. But I'm curious what like the common site preparation strategy.
Yeah, so in the pines, there was either one or two, depending on the rotation, depending on mid-rotation thinnings, and they were kind of commercial thinnings for commercial products, and they did have some revegetation. So we had some basic herbicides. We had a whole consortium spraying technique. You get that down, filter young trees. And then in the native forest, we were trying to promote, really just trying to promote education for simple thinnings. That was quite. Yes.
Thanks for the presentation, and it's nice to see that economic viability sustainability, yay.
We're humble
But
apprentice.
I mean, like we mentioned, a lot of these
Mhm.
and it's really hard to guarantee. I guess Han can talk more about that. So I'm just curious what kind of Australian government provide for landowners. I mean, I guess you can speak private and
Mhm.
what kind of policy or incentive utilization of biomass. Thank you.
Yeah, no, that's a really valid question. And yet, the whole supply thing is, if you don't have supply, you can't invest for a future. And we had the same issues with the private native forests out there, where it was a hodgepodge of landowners. Really hard to develop that cohesive because you need to have a connection. In the federal government case, you need to have, unfortunately, there's been challenges this week, obviously getting go through, but you had to have some support of business around that. Within the pine plantation, that was more private ownership. Make some pretty hard and fast business decisions around that. So there's obviously different iterations we're in. For the incentives, that was a struggle over there, because forestry is like, yeah, it was on the national agenda when all the fires were going on. But other than that, they really didn't think twice about it, and it was hard to get anybody to actually work in the sector. So from a plantation management, there really wasn't any incentive for biomass utilization. And that's why it was purely economics and does this work on a market basis because there's no. There are some emerging talks of subsidies in private native because that's where most fires happen that connected with some federal areas. So that may be advised in the future, but not at present. So that's why when I talk about really understanding nuances, is because half of that or more is not viable. And you have to be close to the market. You have to have a high density. All these factors have to overlay to make that viable. And it will be similar here in Arizona. You have to have the resource. I don't want just any resource close enough to the market where it's not good enough resource where I can actually operationally extract that economically and good enough quality where I can sell it. So if I were one of those guys, put for forest FRI treatment, all those nuances are incredibly important. And if they don't work out, you have to be subsidized to make it. And from a large scale fire restoration, fire treatment, kind of thinnings and everything else, subsidies will have to be made on a lot of coops to make those viable. That's just probably part of it. And in the Australian agenda, they're merging to that concept, and there's a whole lot of research going on, but it's not there yet. It's a challenge everywhere.
I guess I have one. So I thought it was interesting that you talked about the cut to lengths in the thinning stand in what seems like kind of a drier forest. I know that one of the benefits of cut to length reduced soil compaction, and they also cite reduced runoff if you leave that material on the ground. Do you know, like, when you remove that biomass in that ecosystem, did it create problems with runoff, or like what did you base that off of, or some science that went on?
Yeah. So and that's part of the whole equation that I talked about at all was sustainability from an ecological standpoint, hydraulic standpoint. Now, the research I was doing was not connected. It was more looking at, is this feasible economically, and connecting that with other research around the world and the country associated with some of those other. But you're right, it's not a hard and fast rule. And actually, when we were looking at some poultry harvesting systems in those native stands, that just you're dragging tree through some of these bare soils, and that could create increased erosion or other issues That's kind of why cut to length was heard, even though that area, and they're still evaluating it. It depends, and it depends on where you're going to be and what slopes you're at and everything else. Stream. And it depends on the owner, as far as what they expect and what's acceptable as far as when
Oh, okay. So, Barry, thanks again. Michael, thanks again for the taking time to give us sharing some in Australia. So, my question, I'm not a. I saw Rick here behind me. So I'm gonna ask a question up over him. So I saw the law, but the law tree failed. I see the big decay right in the middle under your restoration thinning operation. So I'm wondering about the forest health conditions, and that I guess that's my follow-up question. That kind of forest health is a factor of in Australia.
That's a good question, Han. So yeah, and I know what you're saying. So come the hollowed out stands in some of the forests, and in that particular trial, it was coming from varying species. In some of the eucalypts out there, it's quite common that it actually will, they're not necessarily degraded, but they will. It's very common to have a hollow, just the way they grow. Not always, obviously, not good for saw timber, and I think that particular coop pretty and not very good anyway. So that's the forest health is going to vary depending on location and how it was managed. Yeah, age, location, and different insects in the area. I was looking at purely as a volume consideration and not for saw log, because that particular species wasn't very good for saw. Given the infections and unusual, I think that was the variant of the bark, some bark. But good question. And I'm not going to pretend a dendrologist or a forest health specialist. I kind of look at the operations and but there are those nuances.
You mentioned a product I've never heard of before. Niche project, but a product. But what is wood vinegar? What is the market for that?
Yeah, so that's kind of that. Yeah, that's an interesting one. When in certain pyrolysis techniques, you can generate an oil, a gas, and but a vinegar is more like an acetic acid or some sort of acid base. And I'm not a chemist either, but they were trying to use that as a natural herbicide. So like more like an offset of a vinegar. And there are potentially other industrial that and some emerging overseas. We just kind of started to look at those. And really the guys that were working with the equipment operators, pyrolysis machine, great market, but I had yet to actually see that in action. But a potential industrial scale.
You ever heard of that being?
Not really, no. But it's a natural byproduct that does have some economic value in certain. Another question?
Yeah, I had a question about export in terms of the product itself and if processing what can be exported and where you can export it.
Yep. So the Australian economy is heavily driven on background. The number one export iron, among the top in coal, a lot of raw materials. So there's a precedence for a lot of exports, kind of the way the economy works. And that's kind of why it's such a wealthy nation, really. But in that context, we were shipping out whole logs, right? Some of the old growth stuff, we had specific, actually processing some, there was specific export class of all going to China. There was, and other Southeast Asian countries. So yeah, we were sending out raw material, chips, from all these gum trees, part of their pulp and paper industry overseas. Best chips in the world come from, and pellets. So I don't think there really was a restriction. It may vary based on different state and qualifications, what you could potentially overseas versus have domestically. But the reality is a lot of that market trying to develop that, so that the best market was overseas. That's interesting. More closely related to Europe. But some of the same supply considerations. Had 10-year contracts, for supply agreements, never meeting that.